When you type something into Desmos, it doesn't see a picture, it sees a rule. And a graph is nothing more than all the points, x and y, that make that rule true. That single idea explains how Desmos graphs both lines and circles. Start with a simple line, like y equals 2x plus 1. This equation tells you that for every x, there is exactly one y, so Desmos can treat it as a function. Behind the scenes, it figures out where that line enters the visible window, where it leaves, and then draws one straight segment between those points. Since 2 points completely determine a line, this is fast and precise. The same thing works for most linear equations, even if you type them as something like 3x minus 2y equals 7. Desmos can rearrange that into y equals something and then draw it the same way. For a vertical line, like x equals -4, there's no y equals form, so Desmos instead draws all points with that fixed x value. Circles are different. Take x squared plus y squared equals 25. For a single x, there are usually two y values, one above and one below the center. That means a circle is not a function of x. Desmos can't just march left to right and compute y values. Instead, it treats the equation as an implicit condition. Think of the expression x squared plus y squared minus 25. Points where this equals 0 are exactly on the circle. Points where it's negative are inside the circle. Points where it's positive are outside. Desmos uses that idea to decide where the circle must pass. To do this, Desmos divides the screen into many small squares. At the corners of each square, it evaluates the expression. If all the corners are the same sign, the circle doesn't pass through that square. But if the sign changes between corners, then somewhere inside that square, the value must be 0. That means the circle hosses there. When Desmos detects that crossing, it draws a tiny line segment to represent that piece of the curve. It repeats this across the entire screen. Thousands of tiny segments stitched together become a smooth-looking circle. The reason circles stay smooth when you zoom in is that Desmos doesn't stretch the old drawing. It recomputes everything. As you zoom, the squares get smaller, the checks get more precise, and the curve gets refined. You're always seeing an approximation that's accurate at your current zoom level. Inequalities use the same logic. If you type x squared plus y squared less than or equal to 25, Desmos checks which regions make the expression negative and shades them in. That's why shaded regions take more work to draw than simple lines. So the big picture is this. Desmos isn't drawing shapes it memorized. Lines are easy because they can often be reduced to one y for each x. Circles are harder because they're defined by a condition instead. In every case, Desmos is finding the set of points that satisfy what you typed, and then drawing a fast, accurate approximation of that set on your screen.